Okay, what's going on here today? Here's the first thing you're going to do. It's basically a continuation off what I had you do last Friday. You're solving the equation for x, but again, that's not 3 times x, that's 3 to the x power. So again, what I like to do is just parenthesize the exponent and my base. And then I look for outside there if there's any operations, I need to get rid of them. So I have a minus 7, so I need to add 7. And 74 plus 7 is 81. And over here you got 3 to the power of x. Now remember, there's 2 ways you can solve for x if it's a power. First, you can just multiply 3's till you hit 81, if it works. So 3 times 3, that's 9. Times 3. There's 81, so it's 4. So it's x is 4. Okay, so I don't need to use anything else. That way worked. Okay, now my next one. Again, 4 times 5 to the power of x equals 2,500. So I'm going to make my little exponent symbol, and then I parenthesize the x and the 5 kind of separately. But outside of that, on this side, you have a times 4. Now, you can't take 4 times 5, and let me explain why. If one of the factors has an exponent and the other one does not, you can't multiply them. Okay, so don't try to multiply 4 by 5. What you have to do is the opposite of, you want to get rid of the times 4. So I would divide by 4. I divide, I get 625. So now I know what I'm trying to multiply my 5 out to. At the beginning I didn't know because there was a times 4 there, but now I know what I'm trying to actually multiply my 5 out to. So we have 1, 2, 3, 4. Okay, see if that works. That's not enough, so the answer is not 2. I kind of already told you the answer, not by purpose, so I don't expect you to just know that like that. Well, times another 5, that's 625. So the answer is again 4. The answer is not always 4, just it's kind of dumb luck for us that we got 4 right there. Okay, 3 times 2 to the power of x equals 105. Okay, so we have x is a power to the base of 2. Okay, again, don't try to take the 3 times the 2. You don't want to do that. Okay, now we don't know what we're trying to multiply 2 by because there's a times 3 there, so I need to do the opposite of times. So if I divide both sides by 3, then I'll know what I'm multiplying my 2's out to get. Okay, so let's see if we can multiply 35's out so I can get a product of 2's out to get a product of 35. So 4, 8, 16, 32, and that's over. So that way doesn't work. So it's going to be a decimal. Now to find what the decimal is, that's when we use our log over log on the calculator. Okay. So again, you got to remember that whatever's there goes on bottom. So 2 and then 35. So I take log 35 divided by log 2, and I come up with 5.13. All right, then my next one. 6 to the power of x equals plus 4 equals 32. Okay, first off, 6 is my base, but I got to get rid of the plus 4. Okay, so I'm minus 4, and that's 28. Okay, so we have 6, 30, that's too high, that's never going to work. Okay, so now I do my log over log. So if I can't do it like I'm doing here, and I go over it, then it's going to be a decimal. Just do the log over log. So remember, the 6 goes on the bottom, the 28 goes on the top. And I take log 28 divided by log of 6, and I get 1.86. our next problem. 4 times 2 to the x power equals 32, okay? So, solving for the x, okay? So, again, we don't know what we have to multiply the 2's to till we undo the times 4, so we divide by 4. Remember, don't take 4 times 2, that's not doable. So that's 8, so we got 2 to the power of x equals 8. Now, let's see if I can multiply the 2's out to try to get to 8. And you can do that over here, right here, okay? So 2, that's 4, that's 8, okay? So that equals 8. So that's 3, so its answer is 3. Okay, now minus 4, so you add 4. Okay, I'm sorry, I apologize. I already did this problem on earlier, so we're going to get rid of it, okay? Because that's the same problem as right there. Okay, next one, x equals, so we have 7 to the power of x. Or actually, never mind, I want to do that one, I'm sorry. Yeah, I want to do this one. Just rewrite it, 7 to the x power minus 4 equals, let's go with, I don't know, let's go with 92. Okay, how about that? Okay, so again, because I need to show you, again, what you have to do if you can't. So you're going to add 4. Okay, so base 6 times 36, and that's going to be well over the 96, so that doesn't work. There's no way I can do that, so I do the log over log. So 6 goes on bottom, 96 on top. .55. Okay, next one, again, that you want to set the exponent. Again, the reason I always put that upside down v is so I don't think that that's 7 times x. It's 7 to the power of x. So I really don't know what I'm going to multiply 7 to until I get rid of the minus 8. So I add 8. So that's going to be 343. And now we can go into our process, okay? I could take 7 as my base, times 7 times 7. What's that? Because I knew 7 times 7 is 49. Let's see if there's 3 of them. 343. Okay, so that works. X equals 3. Okay, my next problem. Here's the 4 to the power of 2x. Remember, don't take the 4 times the 2. You can't do that. When this has a power and that one doesn't, don't try that. Okay, so I'm multiplying 2 as my base, but I don't know what I would multiply 2 to try to hit until I get rid of the times 4. So I divide by 4, and that's 4. 16 divided by 4. Now I got to figure out how many 2's it would take to multiply to 4. So 2, 1. There it is. That equals 4. Okay, so it's 2. 2 to the second equals 4. Okay, that's all I have to say on that part. Do 1 through 8. I think you'll be pretty good. And then pause the video, and then you're going to come back and I'll show you how to do this problem solving thing. Now, in this packet, I've got 3 examples, but I'm going to do the first one a little different, okay, than the second 2. Because the first one's going to take me a little bit of time, okay? It's a little easier to understand, but I'm going to let you pick. I'm going to let you pick on how you want to do the example problems. You have to do 2. You don't have to do this one on the back that I wrote, okay? So number 3 you can get rid of. Okay, it says example 1. A bank account contains $5,000. It earns 3% interest each year. How many years will it take the account to get to $6,000? Here's the first way you can do it. Now this is not hard. It just sometimes takes a little while to find the answer. Okay. You put X and Y, and X is going to be your years, and Y is going to be your dollars. And you always want to start the years at 0. Okay. Now, where does my money start at? It starts at 5,000. And what I need to do then with the 3% is multiply it, okay, by taking 100% plus 3%, because you'd have when you're adding a percent, that's what interest does. It adds to an account. Interest means add, okay. So you add it to 100%, even though 100 is not the problem, just a whole percent is 100%. You're adding 3% to it, so that's 103%. So you move it twice to the left. So you're going to multiply it by 1.03, and that will tell you what you have after the first year. $5,150. Makes sense, okay, from here to here. Now, in the second year, I multiply by 1.03. Just keep what's on your calculator times 1.03. 5,304.5. You need to include the decimal. 50 cents, okay. Now, you're like, how long do I got to do this for? Well, until you get $6,000, okay. That's what you're trying to figure out, how many years it's going to take for us to get to $6,000, okay? So, third year, again, it can take long at doing it this way. Just keep that on your, don't clear your calculator if you're doing it this way, though. 5,463.64. If you put 63, it's not a huge deal. But if you got 3 numbers after the decimal, if the third digit's 5 or higher, it could just round that to a 4. So 5,463.64. Okay, 4 years. So we times it by 1.03 again, because every year it's 3%. Okay, that's going to be 5,627.54. Okay, I'm not to 6,000 yet. Okay, 5,796.37. Well, shoot, I messed that up. 1.03. Yeah, I totally got to retype that in. So 5,797.37 times 1.03. Okay. Okay, that's getting close to 6,000. 5,970.26 times 1.03. Bam, now we're over 6,000. Okay. So 6,149.37. So it takes 7 years for us to reach $6,000. I can stop and the answer is 7. So you can do it this way. It does take a little bit of time, okay? Now, here's the other way you can set it up. This goes a lot quicker, but you got to have your ducks in a row. In the year 2000, we're not going to use 2000 as a number, so in that year, the average price of a football ticket is $50. Tickets are increasing by an average of 6% per year. How many years does it take the price of a ticket to reach $75? Okay? Now, the first thing I'm going to do, if you want to do it this way, we've got dollars and years underlined, so always have X be the years, Y be the money. So, and then put per year. You're not going to put a dollars above it because it's not a dollars, it's 6%, and it's increasing, so that's plus 6%. Okay. Now, when it goes by a percent, you're not going to use that line. If you remember, if you don't, that's fine. But there was a line I always made you draw first semester. You're not going to do that. Okay. Like when you first came to our school, I had you doing these lines. You're not going to do that. When it's by, if it was $6, you could, but not by percent. So what you're going to do is put this as Y equals A times B b to the x power. Now here's what a, b, and x stand for, okay? Now in this assignment you're solving for the years, okay? Years. So that means you are solving for the x, because if you look over here, years is x. So leave the x alone, but you got to put numbers in for a, y, a, and b, okay? Now y is money, but there are two money amounts, the 50 and the 75. The ending amount is your y, okay? You're going to put $75 for the ending amount. And the a is going to be our beginning amount, so the a is going to be $50, okay? So again, the y is your ending amount of money, because y is money. This is where we began at. Now the b is when I take the 100% and add the 6%. So that's going to be 106%. So I move the decimal twice to the left, okay? And b is 1.06. Now just put all that stuff in. So 75 in for y, 50 in for a, 1.06 to the x power. Now this is a problem is just like you just got done doing, okay? Make the caret symbol, do the parentheses. The base is 1.06. I got to undo the times 50, so I divide both sides by 50. So that 75 divided by 50 is 1.5. Don't minus 50. A lot of people do that. Don't, okay? That's why the dot's there, so you know to divide. Now, this is what I would multiply by, but there's no way I'm going to multiply 1.06 to hit 1.5. That's impossible, okay? So make a box over here and set up your log over log. That's going to give us the answer, okay? That's going to solve for the x for us. Okay, so you got to put that on the bottom. Whatever's raised to the x power is on bottom, 1.06. And then 1.5. And x equals that, okay? So log 1.5 divided by log 1.06, and that's about 7, okay? So 7 years. Okay, now I'm going to do two more. Actually, I'm going to have you just do one problem in this packet, okay? I'll have you do two. I think I probably need to go over a little more examples than I am, okay? A new car is purchased for $16,000. The car declines in value. That means it's minus by 10% each year. Find how many years it takes a car to get down to a value of $5,000. So you've got dollars and years. So years is X, dollars is Y, dollars per year. Okay, the dollars per year don't exist. Instead, per year is a percent, a minus 10%. So you're going to do the same thing you did. The only difference is you're going to take 100 minus 10 instead of plus 10. So y equals a times b to the x power. Now we have to solve for the years, and years is x. So circle the x. We're not going to put a number there. Okay, now y is dollars, but you have two dollar amounts again. And again, it always works this way. The y and the a are both dollars, okay? The a is a y, but the y is where it ended at, which is 5,000. The a is where it began at, okay? And then the b is taking the 100% minus the 10%, and that's 90%. So move the decimal and you are at 0.90. So now just put the things in where they belong. So y is 5,000. A is 16,000. And then b is going to be 0.90. But it's to the x power, okay? So don't forget that. Now we're going to solve for the x, okay? So I'm solving for x, and also I'm going to put a little box here to the side because that's where I'm going to actually solve for the x at. But first I have to get rid of the 16,000. You don't minus it. There's a dot there, so that means you divide. So over here we still got our 0.90 raised to the x power, okay? Now that's gone. Now on the other side we take 5,000 divided by 16,000. 0.3125. Just do two places, 0.31. That's good enough. I don't want you to have to write a bunch of decimals. So now we're solving for the x's. Well, there's no way I'm going to be able to multiply 0.90 to get to 0.31. I mean, those are decimals. That's very hard to do. So you're just going to go to the plan B with the log over the log, okay? But you got to be careful. Whatever is the x, that is bottom, okay? That goes on the bottom. Whatever is the base of that x power is on bottom. Don't just always put the higher one on top, because on the problem like this, it'll burn you, okay? Bottom, top. The one without the exponent is your top. The product, I should call it. This is called the base, and that's known as the product, okay? The product's always on top, the base is on bottom. So I go log 0.31 divided by the log 0.90, okay? 11, okay? So it's going to take 11 years, about, you can put it up to 12, put 12, go up one, okay? Even though it doesn't round, just put 11 or 12, I don't really care, okay? 11-12, 11 or 12. Put one or the other or both of them. Okay. Now moving on to our next one. You're going to do number 2, okay? A town has 5,000 people. It is increasing in pot, that means plus, by 4%. How many years will it take the population to reach 8,000 people? Now, let's quit drawing that. Okay, yeah, we want to draw the box, my bad. So we got people and years. So years is X, people's Y. So it's people per year. Well, there's no people per year. Each year's a percent, so that's not a constant rate. Keep the per year, but you're just going to put plus 4%. So that's not a linear thing, that's an exponent thing. Now know what letter you're going to leave in here. You're solving for the years, so we're going to leave the X in the problem. So I got to replace Y, A, and B. So again, Y is people, but again, you got two people. Well, the end amount is your Y, okay, 8,000. The beginning amount is your A. So again, Y. And then B, you take 100% and either add or subtract. This one's an add. That's 104%. Move the decimal twice. 1.04. So the Y is 8,000. The A is 5,000. The B is 1.04. And X is the years. Okay, now we have to solve for the X. So when X is a power, we want to parenthesize that and its base. Now anything outside that's got to go, okay? So like we got 5,000 times, we need to get rid of that 5,000, but not by minusing it, okay? We need to subtract it. We need to divide by it. So 8,000 divided by 5,000 is 1.6. We have 1.04 to the X power. Now I can solve by X. I'm going to set this up. And I really don't want to write 1.04 and try to multiply it to 1.6. That is really a crappy process with decimals. It doesn't work almost ever, okay? So you want to use your log over log. So remember, the base goes on the bottom, the product goes on top. If you don't know which one's which, whatever's to the X power is my base, and that's the product, okay? So 1.04 on bottom, 1.6 on top. Okay, be 12. Okay, do number 2. Now this is decreasing, so that means minus, okay? So it'll be 100 minus 50. And everything else the same, Okay, let me know if you have a question or if you're really confused, I can help.